Hi, my name is Shyam. This is my friend Pratik. We are from the CRIS lab in the Department of Computer Science and Automation in IISc Bangalore. My friend here works on multi-party computation. Can you please talk about MPC, please?
Hi, I'm Pratik. I work on multi-party computation and zero knowledge. The multi-party computation is a tool that allow you to uh, perform computation among a set of distrusting parties. They have their private input and they want to together compute some function on their private input, but without sharing their private information or the private input with each other. So that's the main summary of multi-party computation.
Why do we want this kind of a computation? Are there any applications? Are there any practicality uses of these protocols?
Certainly. There are various applications starting from scenarios like where you use ride sharing, you use machine learning inferences for various prediction, then performing various data analytics. All these places we use our sensitive data, and these data are not supposed to be given in public. Either these data are way too sensitive for us to share, or various data protection laws like PDP or GDPR. These laws do not allow us to share our private data with any third party. But at the current age where everything is digital, data driven, we cannot survive without having these services. And to avail these services, it is required to compute certain functionalities, and that is where we use multi-party computation. For example, you can take ride sharing services.
So you mentioned ride sharing services, good. And you also mentioned about uh, keeping some data secret. So can you talk more about this ride sharing service and what is the data you want to keep secret in this particular application?
So, for example, you can consider Ola, Uber, these services.
Correct.
How do you take these services? You give your start location, that your starting point, and the end location, right? And does it ask you for your location access?
Yes, we have to, right? Otherwise, how can we use the services?
So that's the thing, that you are giving away your location where you are at the current time. And with this location information, there are various physical attacks are possible, starting from stalking to various kind of harassment are possible. And this is why it is very sensitive information, and you are not supposed to share such an information with any party, even to a service provider. And we want to get this ride sharing service without sharing our location.
Okay, so you want to use the ride services, but you don't want to share your location. But how is it even possible? Is it even possible at all?
Yeah, that's the beauty of multi-party computation. We use our multi-party computation to perform a computation of matching between two users, let's say a rider and a driver, without revealing their location. And neither the rider or the driver, they don't get to know each other's location, nor the service provider who is providing the service. So without knowing it, it is possible to find the match or check whether they are suitable or not.
So the question is that you are talking of a rider and a driver, but is there a relevance for the service provider like Ola, Uber in this protocol, or they are completely out of business here?
No, our ride sharing solution is as follows, where the service provider will play a crucial role to provide the service. However, they are not going to learn the location information. Without having that knowledge, they can provide the service. And why it is something winning for them? Why would they want to go for such a solution?
Exactly. Yes.
So there are various data protection law, as I mentioned earlier. Maybe not today, but tomorrow it is possible they may prohibit such services, and therefore they should have some solution where they can keep on giving this service without taking our private information. So that is why it is also important for them to have a solution in the privacy preserving manner.
Oh, great. Can you explain a bit more using some technicalities in terms of what exactly your solution provides?
Indeed. So our solution considered two main primary approaches. First of all, consider a scenario where, let's say in the city of Bangalore, ride sharing service is being provided. Here, this whole city's network is considered as a graph. We represent it as a graph, and various landmarks are considered as various nodes. Now, what we want to see, whether two user, let's say rider and a driver, they are raising requests to the service provider, they they give their input in the form of a shared or in the mast, so that from the mast or the shared way, any service provider or any other user does not get to know what the underlying value is.
So the actual inputs are completely masked.
Correct.
Okay.
So that does not give any information about the underlying input. And in that masked input, what we want to check whether either the starting and the ending locations are nearby, or if there is a route defined between starting and the ending location, there is some significant overlap in the routes or not. So that is what we check in a privacy preserving manner.
I see. Okay. So what you're talking of is a ride sharing solution which is very beneficial to the users in the sense that you can reduce the amount of traffic, congestion, possibly pollution also by making use of this RSS solution, but at the same time not revealing any location information about any of the users to any of the parties. The parties can be the provider or the other set of people participating in the protocol. So that's a great solution, right?
Right.
So if you want to know more about our solution, you can look at our paper. It will be available in due course and we will make it available on our website. Thank you very much for watching.
Thank you.